We previously talked about large transformers, big power transformers located in substations, dams, or maybe something about the size of a 50-gallon drum that might be hanging on a power pole. Let's take a look at some smaller transformer examples. The first one right here might be familiar to you in maybe a hall closet or a basement or a garage. This is a doorbell transformer. The black and white leads connect to 120 volts, and this thing just hums merrily along forever as long as it's connected. And then the two screws on the other side are those screws that are going to give you the lower voltage, in this case probably about 10 volts, to run your doorbell or chime. This particular transformer says 10 VA. In other words, 10 volt amps. They're giving you the apparent power because they have no idea what the inductance or capacitance is of the thing you're going to hook to it. So they're giving you apparent power and say, we can handle 10 VA. Meanwhile, if you take a look at, let's say, a power supply for something like a laptop computer, you have something like this many times. If you take a look at this big yellow blob, that is the transformer. Now, something like this can handle, let's say 50 to 100 watts, and the transformer is quite small. That's because this transformer is most likely running somewhere at a frequency in excess of 40 kilohertz. Higher frequencies mean smaller transformers, and 40 kilohertz means that neither you nor your dog will be annoyed by the high frequency whine that sometimes can accompany transformers. Meanwhile, this is an old transistor radio. It has several transformers in it. Two of them, for example, right here with the yellow stripe and here with the yellow stripe, connect the 8 ohm speaker to a higher impedance transistor and act as impedance matching devices. The other one is for the earphone. But a couple other transformers deserve notice. Little black top here, yellow and red. These are called IF transformers, or intermediate frequency. They are part of a tuning system for the radio. In conjunction with capacitors, they formed a tuned circuit and only allow certain frequencies to pass, and therefore are part of the overall tuning of the radio itself. You may not know it, but there is a transformer inside your ground fault interrupter. Take a look at this guy, for example. This is a ground fault interrupter, the thing you see sticking in the wall. If you would open it up in the back, what we have here is a small transformer. Look closely. In that transformer, you are going to see the white and black lead. These are the two leads that supply the outlet itself. And how it works is, if there is not as much current going through one of those leads as the other, that means you have a ground fault most likely. Current is going someplace that it shouldn't be, hopefully not through you. But the small amount of current difference, maybe even as small as 10 milliamps, is enough with the high turns ratio of this transformer, look at all those turns right there, is to generate enough of a voltage to tell the electronics, cut the power, something's wrong. So this can be a real lifesaver, but it relies upon a transformer. Another thing is, here's your electric toothbrush. Now in the electric toothbrush, notice you set it in a holder. This is the holder cut in half, and you take a look at this holder, what do we see really? You cut it in half, see the shiny copper windings there? This is half of a transformer. When you take and plug in your toothbrush, you're completing the other half of the transformer right down here where there's a coil of wire, and when those two things are put in proximity to each other, you form a transformer which will then charge the batteries inside the toothbrush. The batteries are these white cylinders on either side. So this way they can seal up all the hazardous voltages inside the charging platform, and you can charge the toothbrush without having to make any electrical connections. Especially useful in a water environment such as a kitchen or bathroom sink. And finally, now that we're getting into inductive charging, as they call it, with such things as, let's say, cell phones or pad tablets and things like that, again, inductive charging, you are essentially taking two halves of a transformer and putting it together. So the transformer exists not only in the big places where we see power distribution and transmission and all that, but also in your everyday life in several appliances, some of which you don't even realize are transformers.